Good day, students. Today we will be discussing about simplifying trigonometric expressions. After finishing the module, the learner should be able to apply the fundamental trigonometric identities, apply the double angle formulas, and simplify trigonometric expressions. Let us recall the fundamental trigonometric identities. We're going to use reciprocal identities, quotient identities, and Pythagorean identities. We will also be applying the double angle formulas. Now, let us simplify the following trigonometric expressions. First, let's have sine theta over cosine theta tangent theta. So, we change tangent theta into sine theta over cosine theta. That's the quotient identity. And then, cancel cosine theta. We're going to have sine theta over sine theta, which is equal to 1. Next, let's have 1 minus sine square x over 1 plus cosine x. So, we change the numerator sine square x into 1 minus cosine square x. It came from the Pythagorean identity sine square x plus cosine square x equals 1. And then as you can see, 1 minus cosine square x is in the sum and difference pattern when factored, because it is in the difference of two squares. So, now we can cancel 1 plus cosine x. It will be 1 minus 1 plus cosine x. And 1 minus 1 equals 0. So now we have cosine x. Next, let's have 2 sine x cosine x over 2 cosine square x minus 1. So as you can see, 2 sine x cosine x is a double angle formula, as well as the denominator 2 cosine square x minus 1. So we can change it into sine 2x over cosine 2x. Okay? And then sine over cosine is tangent. So we can simply express it as tangent to x. Applying next, we have 1 minus secant square theta over secant square theta. So we can separate it into two terms. It will be 1 over secant square theta minus secant square theta over secant square theta. So since the numerator and the denominator are the same, we can express it into simply 1. Now we have 1 over secant square theta minus 1. So as you can see, we can use the reciprocal identity. 1 over secant square theta can be expressed as cosine square theta. Okay? And cosine square theta minus 1 can be changed into sine square theta, applying the Pythagorean identity. So here are the identities and formulas that we need to remember. Now, let us have proving other trigonometric identities. After finishing the module, the learner should be able to apply the fundamental trigonometric identities, apply the double angle formulas, and prove other trigonometric identities. Again, we will be using the fundamental trigonometric identities such as reciprocal identities, quotient identities, and Pythagorean identities. We will be also using the double angle formulas. Now, let us prove the following trigonometric identities. First, let us prove if cosine square theta minus 2 is equal to cosine 2 theta over sine square theta. So let us start on the right hand side of the equation. So look at the numerator, cosine 2 theta. We can apply a double angle formula for cosine 2 theta. We can change it into 1 minus 2 sine square theta. Okay, and then let us separate the numerators. It will become two terms, 1 over sine square theta minus 2 sine square theta over sine square theta. So we can cancel sine square theta in the second term. It will be simply 2. Now we have 1 over sine square theta minus 2. And we can apply the reciprocal identity. We can change it into cosine square theta. So now we have cosine square theta minus 2. Next, let us prove if tangent theta, cotangent theta minus cosine square theta is equal to sine square theta. Again, let us start on the left-hand side of the equation. So, for tangent theta and cotangent theta, we can apply the quotient identities. Okay, so we can cancel the similar factors in the numerator and the denominator. So, it will be simply 1. Now we have 1 minus cosine square theta, and we can apply the Pythagorean identity. So we can change it into sine square theta. So now we have proved this trigonometric identity. Next, 1 plus sine 2 theta equals the square of sine theta plus cosine theta. So let us start on the right hand side of the equation. So as you can see, sine theta plus cosine theta square, we can expand it using the concept of squaring a binomial. It will become sine square theta plus 2 sine theta cosine theta plus cosine square theta. So applying the commutative property of addition, we can write together sine square theta plus cosine square theta. Okay? And then as you can see, we can apply the Pythagorean identity in that group. So it will be simply 1. So now we have 1 plus 2 sine theta cosine theta. And we can apply the double angle formula. So now we have 1 plus sine 2 theta. Next, let's have 2 sine theta over 1 plus tangent square theta equals sine 2 theta. So we can apply the Pythagorean identity in the denominator on the left hand side of the equation. So we can change it into secant square theta, okay? And then for the tangent theta, we can apply the reciprocal identity. Let's change it into sine theta over cosine theta. In the secant square theta in the denominator, we can also apply the reciprocal identity, change it into 1 over cosine square theta. Okay? And then we can simplify this expression into lowest term. The result will be 2 sine theta cosine theta. Okay? And as you can see, it is a double angle formula. So we can simply express it as sine 2 theta. Remember, class, that we can use the fundamental trigonometric identities and double angle formulas to prove other trigonometric identities. You can also use the other trigonometric identities that we have derived from the previous lessons. Always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next time in our next lesson.